Hello and welcome. My name is Shannon Kemp and I'm the Chief Digital Officer at DATAVERSITY. And we would like to thank you for joining today's DATAVERSITY webinar, Mastering Data Modeling, Understanding Conceptual, Logical, and Physical Models. It is the latest installment in a monthly series called Data Ed Online with Dr. Peter Aiken. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. For questions, we will be collecting them via the Q&A section. And if you'd like to chat with us or with each other, we certainly encourage you to do so. And just to note, the Zoom chat defaults to send to just the panelists. We may absolutely change that to network with everyone. So to open the Q&A or the chat panels, you can find those icons in the bottom middle of your screen. And to answer the most commonly asked questions, as always, we will send a follow-up email to all registrants within 2 business days containing links to the slides. And yes, we are recording, and we'll likewise send a link to the recording to this session, as well as any additional information requested throughout the webinar. Now, let me introduce to you our speaker for today, Dr. Peter Aiken. Peter is an acknowledged data management authority and associate professor at Virginia Commonwealth University, president of DAMA International, and associate director of the MIT International Society of Chief Data Officers. For more than 35 years, Peter has learned from working with hundreds of data management practices in 30 countries, including some of the world's most important. Among his 13 books are many firsts, starting before Google, before data was big, and before data science. Peter has founded several organizations that have helped more than 200 organizations leverage data-specific savings, which have been measured at more than 1.5 billion US dollars. His latest is Anything Awesome. And with that, let me turn everything over to Peter to get today's webinar started. Peter, hello and welcome.
And hi to you, Shannon. Hopefully my mic is unmuted because I lost my visual right now. You can hear me okay?
I can, yes.
Good, excellent. Well, good to have everybody with us. Thank you, Shannon, for that. Let's jump right in here and take a look at what we're going to talk about today. The real key for this is understanding that we have 3 different types of modeling, and unfortunately for most of us who are data professionals, people who are outside the data profession don't care about any of the topics we're going to talk about today, but it is still nevertheless important because these represent tools in your data professional toolkit that you can use in order to do this. So we're going to start off with a little bit of an introduction to data modeling, talking about what we need to understand how data modeling is used for. Then we'll dive into the 3 types: conceptual, logical, and physical data modeling as we dive down there. Then, of course, we'll come back to our Q&A, which is the part that Shannon and I enjoy quite a lot as well. Let's dive into this and take a look, getting us started here. First of all, it's really critical when you're talking to people about the motivations for doing data modeling that you impress upon them the importance of data expansion. Data continues to expand at an expanding rate, if you will. And this is a company that I've used for years, Domo. They collected data for about 10 years and then for some reason stopped doing it. So this is the last time that they did these measurements. But for the entirety of the year 2022, every minute of every day, Facebook users shared 1.7 million pieces of content. That's 1.7 million pieces of content every minute for the entirety of 2022. You can see the rest of the numbers that are up there. Amazon shoppers spent $433,000 every minute of every day. Amazon making less than a penny on each of those transactions, nevertheless adds up to still enough money to send Jeff Bezos off to Venice for a wonderful wedding last week on all this. So all of these are really incredible numbers, and you can see them perhaps a little bit better here when we look at the increases across the 10 years that Domo.com did collect these from 2013 to 2022. Google queries tripled. YouTube hours very much by an order of magnitude. Instagram, much success. Twitter, Facebook, lots of emails that were sent. And another graph that I like to use to help to illustrate all this is that since the beginning of the digital age, slightly before 2000 here, you can see that the amount of gigabytes has gone up to way more than existed even before this. So we're creating more each year than existed prior to all of the digital age in terms of looking at these. It's just an incredible amount of it. And what really is important for us as data professionals is to understand that while the supply of data is growing at an increasing rate, our abilities to analyze it are not increasing at the same rate. And that is a huge, huge problem. There actually are some numbers that go beyond this. We can look at the specifics, but it just doesn't matter. We're not even close in terms of keeping up with all of this. And what this leaves us with is an absolutely staggering amount of data debt that organizations are faced with. And this lack of understanding the data debt is primarily due to the fact that most people have no real way of dealing with it as a model. And that I'm going to go back to that because I didn't finish making my points, which is that whatever it's doing, this is a point you can help to your business partners understand. It slows progress, it decreases the quality of whatever's going on, it increases the costs, and it greatly increases the risks that are associated with it. So let's start off by defining data relatively precisely. And this is, again, important if you are trying to illustrate this to others who are not understanding this. This is the outsiders. Most data people get this pretty well. If I start off with just the fact 42, you may say to yourself, okay, 42 is a fact. What does it mean? Well, let's look at what it could mean. 42 could be the answer to life, the universe, and everything coming from the Hitchhiker's Guide to the Galaxy. Could also be Hank Aaron's baseball jersey, and in fact, the title of the wonderful movie about his contributions to this. And 42 is my age, 23, 24 years ago now. Meaning that if somebody was asking the question, am I allowed to consume adult beverages in the Commonwealth of Virginia, the answer to that would be yes. So I have taken the fact 42 and I've paired it with 3 different meanings here for you. This is what our profession is all about. And it's important to understand that while all of this data is interesting, we're really only interested in the data that is useful for us making decisions. So 42, you still have to clarify, are we talking about baseball? Are we still talking about drinking? Or are we talking about the Hitchhiker's Guide to the Galaxy? Each of these, again, very important all the way around. So here's our definition of data. It's a fact paired with a meaning. You can see I've paired it with 3 different ones already. And more importantly, is this data useful to us? Because one of the biggest problems that organizations have is trying to get a handle on data that is not useful to you. It's a big data science problem. We'll talk about that in a little bit, but it nevertheless keeps us focused in on things. So now we get the next part of this. What's the difference between data and information? Information is data that has been requested by somebody for some purpose. So while we have lots and lots of data, most of it is underutilized, and that only a smaller portion of that actually becomes information. So one of the things that we as data professionals are very concerned with is how are people using data? Are there patterns to it? Is there a particular type of data that is more useful than others in there? And notice again here, this is all being put together in the form of a model. The model is data is paired with a fact, pairing a fact and a meaning. Information is pairing a request with some useful data so that somebody will make use of it. This leads us to the point where you can say we can have data without information. In fact, oftentimes do, but we cannot have information without data. So a wonderful way to help thinking about it. That last piece of this, what is this sort of intelligence? And over the 30 years I've been doing this business, this top level was often talked about as knowledge or wisdom. It's how that information is used strategically in the organization. Now, I've written the business rules for each of these out down below here. So you can see there are 5 business rules. Each business rule captures the model, but you can see that the model is much easier to understand than it would be if I just presented you with the 5 facts that are down there at the bottom of that. And lastly, this arrangement of these icons, in this case, factoids, the model representation, is organized into an architecture. So this is a model of the difference between data, information, and intelligence. Once again, you're welcome to use these slides as always. This is probably one of the slides I'm most requested for. I'm very happy to share it. I did not create them. They were shared with me by a fellow named Dan Appleton back in 1983. It's just a shame that we don't have more of this sharing going on, because, of course, if we did, we would have everybody being smarter about the overall process. So let's move from this model here and talk about a data structure as a model here as well. Here's a data structure showing, in this case, relationship between customers, sales orders, products, and sales order lines. Again, lots and lots of things that you can put out. This is a very abstract definition, but the definition from a computer science perspective is an organization of information, or in this case, data, that allows us to do things. And while it does things, it does them for a purpose. So again, the way in which we arrange the data, the information, can be done for algorithmic efficiency, for processing, for storage, a lot of different ways of doing this. If we don't make a conscious effort at it, then we rely on technology to do this. And I can't tell you how many parts of that $1.5 billion that Shannon mentioned at the beginning here have come from just helping people organize their data to more correctly support their strategic objectives on this. The goal, of course, of all of this is to have as few organizations of data as we possibly can. It doesn't mean we can get to zero, because that would be super silly. And one is also a super silly number, although there's a process in most people's graduate education when you're looking at this, that you realize you can store all data in a single table that is simply self-referential. However, that would be optimized in no way to support strategy. So the goal is to keep these things under control, to make sure that we do not have any more of them that we need, but that we do have as many as we do need. And the reason for that is very straightforward. If we look at the number of interfaces that are required to arrange data between applications 1 through application 6, if the organizational objectives indicated that all data needed to be able to talk to all other applications in here, the answer to how many interfaces we would need to create and maintain is n times n minus 1 divided by 2, or in this case, the number 15. Now, this is true no matter whether your data is in the cloud or on premises. And most people think that while I've moved the data to the cloud, I don't need to pay attention to this anymore. In fact, just the opposite is true, because the cloud generally has fewer options available to you than you do on premise. And therefore, if you are trying to make sure that your data models support your organizational objectives, you need to make some choices in here in order to do this. Let's just take a look at what happens. I'm giving you a very simple example here with the number 6. The Royal Bank of Canada told me I could use their numbers for a few years back. They had 200 major applications and about 5,000 interfaces between the 200 applications. So let's do a little bit of math. If I do the n times n minus 1 divided by 2 on here, you can see that at 660, 600, the numbers become quite large. And in this case, if we plot the Royal Bank of Canada on this graph, we can see they are above average by only having to deal with 5,000 interfaces. This is an absolutely good, valid statistic on this. And if you have the same numbers for your organization, you can determine whether you are above or below average in this case. And I say average, actually, it's the worst case scenario in this instance. To take a look at this. So the more interfaces, the more data structures you have, the more interfaces are required. The more interfaces that are required, the worse off the complexity, the data rot in your organization is in order to have to deal with it. I contend that data rot accounts for 40% minimum, sometimes as much as 60% of all organizational IT costs. And that is a very large number for some organizations. So why do you look at modeling? Well, a good example, once again, to take back with you to your customers is, say, would you want to build a house without an architectural sketch? The model is the sketch of the system. the house, in this case, to be built? Would you like to have an estimate of how much your new house was going to cost? And your model gives you a very good idea of how demanding the implementation work is going to be. If you hired contractors from all over the world, would you like them to be guided by a common language? The model provides this common language to all the data in your organization. Would you like to verify the program proposals before the work gets started? Yes, the model can be reviewed before thousands of hours of implementation work are spent doing the wrong kinds of things. If it was a good model of your data, would you want to build something similar over again rather than starting over? You can use the model to create the next version of it to create on this. And if you're going to maintain your model, the model is going to tell you, just like the blueprints of your house, where you can and cannot easily make changes. And if you do have to make a difficult change, how to make that difficult change safely. Once again, super useful articulations on these things. Please feel free to take these slides and recreate them. Now what I'm going to show you is what I call my washing machine model. I know it's a weird version of a washing machine, but it really describes the overall taxonomy, if you will, of modeling types that we're using in here. It's a three-dimensional model. It starts off on the first dimension with as is. That's how things are currently. I actually had a DAMA board meeting this morning, and we talked about the difference between as is and to be. It's something that has important implications. To be is the pie in the sky, what we'd like it to be. I don't mean pie in the sky as being a bad thing, just that we have our existing system and we have what our system would be after we make whatever changes it is we'd like to do this. So this is one dimension of the model evolution framework. The second dimension on here is equally important. All of your models are either validated or unvalidated. If they're validated, it means somebody has said these are correct and true models. I tell people that any model that is not validated should have the word draft on it, because of course, very difficult to basis. You're sort of hoping that it's the right model rather than knowing that it's the right model in this case. So our first dimension was as is and to be. Our second is validated and unvalidated. Our third one brings in the topic of our webinar today, conceptual, logical, and physical modeling. All modeling efforts take place within this particular framework. And the way it works is when we're doing modeling, we tend to only teach forward engineering, which is an unfortunate characteristic that happens here. But we start out with a requirements document. We then make a model of that, and then we make a physical implementation. In this case, it would be the data structures, the data store, the database that we're putting in place in there. All modeling changes can be mapped to some sort of a transformation within this framework. And that's important to understand because it does limit what we're doing. It also says we have a limited number of choices that we have to make, but it also means that the choices that we make are pretty important in order to do this. 50% or more of IT work, though, involves some sort of reverse engineering, the opposite of forward engineering. Oops, I said 50%, it's 80%. Sorry about that. The idea here is to start with our physical as built and move back to a logical component of this and take that logical component sometimes into the conceptual components here as well, working backwards. And while this is not well known, it has become a topic in most database textbooks, which is different from what we have. So we're moving, in this case, the blue arrow from physical to logical and from logical yellow arrow to conceptual. I only need to go to conceptual if I'm actually changing the requirements. If just the design is changing, I can stop after the blue arrow's implementation. The formal definition is evolving existing systems using a structured technique aimed at recovering rigorous knowledge of the existing system in order to leverage enhancement efforts. Now, I'm going to take that model and turn it on its side here. I apologize for being a little bit discontinuous here, but it is important to understand that these also map to the ANSI Spark architecture for databases, which is the, physical, logical, and conceptual layers out here. So the key to all of this, of course, is to understand that there is a trusted catalog at the heart of this. It's very important to make sure that everybody understands these things as all being the same kinds of things. So we have our representation. The logical model fits somewhere between that conceptual and physical model, but you'll see in a few minutes it does have a absolute purpose in order to do this. So this ANSI schema gives us conceptual, the highest level of abstraction, logical, a refinement of the conceptual model, and physical is the implementation of this. Another way to think about this is that the physical model is how the technology works. The logical model is how your organization or how the business works. And most of the time, your conversations with your colleagues, counterparts in the business community are not going to be about the physical level. They're going to be about the logical level. We'll see how that works out as well. But the real key is to understand that the physical part is not something the business is going to be concerned with or should be concerned with in order to look at this. So let's go back to our washing machines here. Again, forward engineering is the process of going from what to how to actually building it. And unfortunately, we spend only 20% of our investments in IT and digitization, and in fact in AI, in building new stuff. 80% of our investments are all done to enhance existing stuff, to leverage existing components, to make what we have better in order to do this. And that is a tremendous important, but it also means that you all, as the data management professionals, are going to be the best qualified to look at this. So let's look at the reverse again as we come back on this. We don't tend to teach it, but we need to come back from our physical as is to our logical as is. And now you know the reason for that is so that we can converse with our business customers about things, if nothing else, about the strategy. In other words, they say to you, well, we're just going to store customer information. Why would we want a strategy around that? And the answer is, well, if you're planning to process hundreds of thousands of customers per second, as we were seeing some of those data numbers earlier, it can become critical to arrange your data structures, your data models in such a way that will work. If we're going to actually change the what we are doing as opposed to the how we are doing it, then it becomes important also to reverse engineer from your existing design to your existing conceptual model. One last piece on this that you'll hear, and this is something that happens over and over in organizations, they will say they are re-engineering something. Re-engineering has a formal definition. It means to first reverse engineer the existing systems. Why would you want to care about what the existing systems are like? Well, every system has its good points and its bad points. What we want to make certain of is that we ensure that the good things are preserved in the next version of it and that the bad things are improved. If we don't, what was the point in moving it? And by the way, this happens every time organizations move it to the cloud, but they don't think at all about these considerations. This is where you can engage people in the design and say, prove to me that the investment in moving this to the cloud will in fact result in faster, better, cheaper, or less risk in order to do this. So again, reverse engineering from our as is, and then lesser extent, sometimes we need to change what we're doing in order to do that. And then we use this information to inform the design of the new system. Once again, I can't tell you how important this is, but I see this step missing all the time. So we now understand our conceptual, we now move from our as is to our to be requirements assets. Sometimes we don't have to do that. We can simply go straight from logical to logical. Either way, we're going to use this information to inform the design of the new system. And yet, when we look at how this happens in the real world, almost all the time it follows this pattern. I have data, and I take it from place A, and I forklift a copy of it to place B. We're missing, notice, all of those other steps. And the reason for that is twofold. One, people are not aware that it needs to be done, but in the cases where they do need to do it, it still falls prey to what I call the 2 T's of system construction. And that is training, testing, and transformation of the data. Those places always usually get cannibalized because other parts of the project don't tend to work as well, and consequently they have to compress the schedule in order to meet an arbitrary IT-based deadline on this. So once again, key here is that most organizations will simply lift and shift the data directly from one place to another and make horrible mistakes in the process. Again, if I was to bore you to tears with the number of times I have had to help organizations out after they've already done this, and sometimes it ends up in a lawsuit, it'll keep you entertained for an hour, but you won't do a whole lot in terms of the modeling pieces on this. Let's, now that you've got this construct in mind, take us to another aspect, which you can see the word normalization written up at the top of the page here. Normalization is really the idea that in any case, we're going to have a situation where somebody needs to do something. Again, remember our little mantra there: first reverse engineer the existing system, and next use this information to inform the design of the system. Now, what they teach in normalization is that you should go through this cycle minimally. Remember, I said you need to go to the requirements pieces of it, if and only if you are getting into the changing of the requirements that are there. That's typically not the case in most instances, so we'll keep it confined to these 4 quadrants that occur here. And that sounds great. So we're going to start off with this green thing being the existing database. And then we say to everybody, yes, first you reverse engineer this piece in order to come up with the existing system, going from our physical as is to our logical as is. If we still have the documentation from when the system is built, that step is oftentimes unnecessary. However, I would say about 50% of the time, people don't occur this, and that number is increasing these days as more and more people are placing their trust in cloud-based systems that they don't know anything about how they function. The purpose of doing this is that we've also moved from what we call technology dependency to technology independent. Everything that is physical, everything that is Oracle or Amazon or Azure specific is removed from there, and we have a logical model in order to look at this. Then what, of course, we say is you need to move that to the logical to be system and then move it over there. And most people at that level of explanation, which is quite frankly how it is taught in most of our educational systems around the world, look at this and say, well, why shouldn't I just lift and shift this stuff? What do I gain from doing that? Of course, the key is written there, right there on the slide. If you don't understand what works well and poorly about the existing system, you are likely to make those mistakes and make things worse in the new system instead of better. At best hopes, we hope that nothing would change, but in all likelihood, since this is an opportunity, you have the opportunity to make things much better. Let's go another level of explanation on this, and that is usually the case that when I reverse engineer something in order to do some normalization, I'm not just doing it with one pile of data. I'm oftentimes integrating additional data that comes in here. So I've changed that green blob to be a combination of green and orange in order to do that. That is the main thing that helps us to understand the rationalization of it, because integrating that additional data component, and I have looked at literally thousands of programs that teach this stuff, and not a single one of them says, oh, by the way, in the normalization process, you're going to add some data types, some data structures, some data models into this in order to come up with a new version of this. It just is never taught. Once again, we move from there to this technology independent model on the other side, but notice now it's not the same green one, it's now an orange and green one in order to move these all the way through. Let's now ask a little question, and I happen to use Gemini a lot, mainly because I'm asking my AI a lot of questions about YouTube videos, and as you might imagine, Gemini is pretty good at reading YouTube videos, whereas most of the rest of them are less good at this, being that YouTube is a Google product. So here's a question. A database table consists of the following rows: ID, purchaser, song, price. Is the table normalized? And by the way, even in this example here, if you aren't catching this, the word rows there should really be columns, but nevertheless, the AI figured out what I was doing. It says, yep, you're thinking about database normalization. So what are the deals about whether your thing is normalized? Well, they actually got these correct definitions: data redundancy, update anomalies, deletion anomalies, even though I asked the question incorrectly on this. And to normalize them, it gives the next set of steps that occur in that process and talks about the benefits of normalization and the different normalization levels, how rigorous you want your normalization to be in order to do this. This is to say that if you're not using AI as part of your modeling efforts, you're taking unnecessary amounts of time. The key, however, is to look at this collaboration process with the AI as just exactly that. You want to go in and have it help you and have it try to find things that are incorrect. What are the areas of greatest risk? What are things that would work and not work in order to look at these concepts? A very, very clear example of this, you can take your DDL and feed it into the normalization routines, and it will find these things. Now, I hope that most of you are not seeing the Zachman framework for the first time here. John's been a friend for many, many years and a leader in our field. And if you look at this, even his table right here keeps track of. Think of this, if you're seeing this for the first time, as a way of organizing your metadata. Very, very nice way to do it. It's not the primary purpose of the table, but it is another side benefit of it. But those what and how pieces that are circled in yellow here, and I'll enlarge that section, actually now map us directly to conceptual, logical, and physical modeling. So this is not a new idea. This has been around since the inception of these models. And I'm going to show you now a little bit about conceptual data modeling using the analogy of a bridge. This is the Millau Viaduct in France. It's the highest bridge in the world as of 2007. Don't worry, they're still bringing bigger ones out there, but nevertheless, you can see it's a pretty awesome structure in order to do this. The previous way of getting from place A to place B was to follow the red route, which was much longer in terms of time, as opposed to using this bridge that gets us from one set of mountains to the other and shortens considerably the journey in order to do this. As they were looking at these models, they started off here and said, this is business focused. Why are we doing this? Well, we need to have the A75 get people to places faster than the N9 in this case, across the River Tarn and across that. It is generally at the conceptual model stage simply entity levels. We're not dealing with relationships or anything else. We provide focus, scope, and guidance to the modeling effort. We more often than not throw them away when they're done, rarely maintain these types of models. From a logical perspective, now we have to convince people how we're actually going to build this bridge. Everybody says, yep, that'd be a great idea. I'd rather go shorter than longer in order to do so. How are we going to build this? Well, the tallest pier is taller than the Eiffel Tower, certainly a structure that everybody in France is familiar with. And the way we're going to build it is with this carriageway that is very rigid, very light, and yet very strong in terms of putting people across this. So we're developing these logical models to the attribute level and understood at minimally at third normal form. Logical models are developed to be refined until they become a solution. This is one of the hardest lessons that I have to teach my students. The first version of this model is likely not going to be the version that's going to be optimal for your project, particularly since the first version rarely takes into account the strategic considerations in order to do this. Again, showing the rigor that's associated with this, we now have the ability to get people to say, okay, it can be built. We should actually maintain this type of thing. And here is the physical model of this. How did they actually build this? Well, you can see they built a bunch of temporary pieces. Those are the ones in red that are there. And those pieces in red are then removed after they put the road across it, because an important component of this bridge was the appearance as well, in order to come up with. And I'll just show you a little quick bit of how they did this. This is an enlargement of that particular piece. So here's, first of all, pieces put out. They push them across these tops. You can see it's a highly sped up animation. It took them a long time to do this. But once they took those two sections and cemented them, I shouldn't say cemented because that wasn't the right word, connected them together, the entire structure became structurally intact in order to come up with this. Very important. And how did they actually do this? Well, again, you can see the use of the model here. Now what we're going to do, oops, I'm so sorry. Got to go back and run through that one again. Put the pieces up on there, get them to come up, connect them all. Once it's connected, we have a much stronger piece. And now, once we've got them connected, there we go, we have the model. Made the keys too fast. So what's happening here is, you can see this is how they were moving it. Obviously, it was not as fast, but very, very slow and careful in order to move these large sections of the bridge from place A to place B. They moved these things apart, lowered it, came back a little bit further here, and moved it the next piece little bits, 2 feet at a time, in order to move these things, but quite effective as a building technique. In order to do that, of course, they created this absolutely marvelous piece of engineering work. And this is some of the things that you all are doing with your data modeling efforts if you do this. The efforts are very much the same way. We could go the old way or the new way. Well, we could do this. We've got a lot of details. We're going to organize those details at the intricate level to keep track of the intricacies in your business, to larger components that are organized in the models. These models include the concept of dependencies at this level. And finally, we organize those larger models into an architecture, and this gives us a purposefulness type of activity. Same thing, of course, happens in the data. The attributes represent the intricacies. The dependencies are done with the entities, and the attributes. And a question comes up a lot. Why don't we see too many of these large data architectures? Well, one of the reasons is because they're not much good in this form. They're much better off in something we call a case tool, computer-aided software engineering course tool in order to do this. Data modeling processes, iterative, as I mentioned before. They're developed in response to organizational needs. And this data model, even though I don't show it, should evolve over time as it articulates and authorizes specific information systems requirements that will evolve over time. And if we don't keep track of them with a trusted catalog, we won't have the results. But you can see here the iterative process of going through and evolving our organizational needs. Failure to do any of this results in something I call the princess on the P model. Here's the P down here at the bottom. Here's the princess up here at the top, with sleepless because of an imperfection. And similarly, if we get these imperfections incorrectly in here, it locks in these imperfections for life, and it restricts our alternative benefits that I mentioned before. 40% of IT budgets are involved in migrating, converting, or improving data models. Help us to avoid all of the rest of these risks. I mentioned the different types of the models. Here's the database we were looking at before: purchaser ID, song, price. And if we look at this and say, what information would be lost if I deleted record number 1? Well, I would lose 2 facts. I would lose the fact that I purchased a song called We Met Today, and I would also lose the fact that We Met Today costs 99 cents. Similarly, these are usually undesirable and unintended. We go to an insertion anomaly. What if I wanted to add a new song called Scuba and it cost $1.29? The answer again here is that we can't enter it until somebody actually buys Scuba. We can't insert a full row until we have an additional fact about that row. Once again, this is unintended and undesirable around that. Finally, the updated anomalies. What if I want to increase the price of We Met Today from from 99 cents to $1.29. And notice I spelled We Met Today incorrectly here. And so it would not catch that particular error. Once again, all of these are different types of errors. So there are correct ways of organizing the data. Organization can be done for flexibility, adaptability, retrievability, risk reduction, and the techniques include data integrity, smart codes, or lack thereof, right, and architectures, tables, and joins. In order to do this, our way in this instance is to store as much as possible one fact per row in order to do this. So it shows both that purchaser number one has purchased sushi live, that it costs 99 cents, two distinct facts that should be stored in two separate tables. Here's how that table should work. We should have a simple pricing table on the left-hand side there, and that pricing table, when it changes the price of all the purchases that are there in order to come up with this. The problem is all of these result in sand getting into our machinery. Really problematic from a factual perspective, not well understood in terms of all of that, and that we need to make sure that the sand doesn't get in there. And take a look at it. Let's take a look at the conceptual components here again. Remember, this is the left-hand side of the double stacked washing machines in my very poor metaphor in order to do this. And what's happening really here is that we're trying to get vocabulary standardized. We're focusing in on what are the strategic issues and trade-offs that are involved in it. What are the requirements that satisfy the specific business objectives? Again, remember the word draft needs to be on all unvalidated models, indicating a lack of certainty. Notice that my little icon for that is a fingers crossed sort of piece in order to do that. It helps us to organize the data concepts, gives us relationships. Sometimes they're only at the hypothesis level, and making sure that we include these things in validated models in all cases on this. We want to make sure that we understand high-level interactions with processes around this. I mentioned before, architecture always involves trade-offs. Again, good, cheap, or fast. Well, you could pick any two and get it to work, but you can't have all three simultaneously. Let's talk a bit about strategy, just very, very briefly. Most people overuse the word and over-engineer their strategic concepts in here. We didn't even use the word strategy until about 1950, when the management consultants discovered they could make a lot of money by selling, quote, strategies to people, which usually ended up being hundreds or thousands of PowerPoint slides and pieces of paper that nobody ever takes a look at from that point onwards. The better way to look at strategy is, instead of thinking about it as a thing, which is what the management consultants want you to think of it as, is to go back to our original use of strategy, which is derived from the military, and their definition is a pattern in a stream of decisions. This means that strategy is a process rather than a thing. Let's take a look at a couple of examples of this very quickly. Walmart's former business strategy was everyday low price. That's pretty easy, and everybody in the organization, from top to bottom, understood it. Wayne Gretzky, a hockey great for Canada. Sorry, Canadians. Again, his idea was he skates to where he thinks the puck will be, because if you're chasing a very dense piece of plastic around on the ice that travels much faster than anybody can skate, the idea of catching up with the puck is silly in these circumstances. So he went to where he thought the puck was going to be and became an absolute soccer great around that. Here's one last quick example on this. Napoleon facing a large enemy. How do I defeat the competition when their forces are bigger than mine? The answer is divide and conquer. Pattern in a stream of decisions. Because what happened here was that the blue army, that's Napoleon's, had to hit the red army and the black army, both of whom are the enemy. The red are the British, the black are the Prussians in this case. They had to hit them in exactly the right spot to make them spring apart. Well, that's a great idea, because if they got them to go apart, then Napoleon could take the army and turn around and attack, in his instance, first the Prussians and then the British. In this case, his smaller army could defeat the larger army. His strategy didn't work, and that's because it was a complex strategy. In other words, remember, hit both of the armies at just exactly the right spot so that they will retreat in opposite directions. And then everybody turn to the right, defeat the Prussians, then everybody turn to the left and defeat the British, and do this, by the way, while somebody is shooting at you the entire time. Well, I hope you agree with me that this is a complex strategy and has been a difficult thing for organizations to actually do. So when we look at data from a strategy perspective, one of the things that could happen here is for efficiencies. I can remember back as I was working for a retail organization, they had a situation set up where managers were told to sell because they needed to get more from less, right? So managers were selling, and so the attributes of sales were not able to accrue to a manager. And what happened was they had to make 2 entries into their employee files where they had employee. I was Peter 1 as a manager, and I was Peter 2 as an employee because I had a sales quota that I had to meet in order to come up with these things. Here's another example all the way around. Sabre created the flight booking business. If you aren't familiar with this, this is now Travelocity, I believe, that has come up to. And that AT&T was able to create a brand new credit card business because they had everybody's phone number and whether or not they were paying a lot or a little for their phone services, and whether they paid their bills on time, which was a good measure of credit worthiness. And Amazon, of course, invented the home retailing by starting out with books and then figuring out that now they had everybody's information about books. They could sell them lots of other stuff. In fact, Amazon days have already started, so you can go out and shop to your heart's content and pay for Jeff's wedding. I think I pulled that one out already. And Capital One actually had a good altruistic mission of trying to help people who had credit needs that were unmet in order to do that. Let's take a look at how you would build this type of model in here. It's one, identify the entities that are out there and just put a label on them, whatever they are, and then identify a key for it. In other words, how am I going to differentiate Peter 1 from Peter 2 in that table in order to do this? Then draw a rough model of that diagram, just sort of pulling things together. Very, very useful, very, very helpful in order to do this. Identify attributes and assign the attributes to each entity in order to do that. And again, most instruction stops here. We have to go through one more process of evolving the model because we're likely to discover things that we didn't when we looked at it the first time. So these models evolve over time as you're working your way to it and as you're learning more about the specifics of the organization's needs that you're trying to meet strategically from these data modeling pieces. Here's a model of the state of Virginia's Department of Social Services from a strategic perspective from a couple of years back. They had 5 distinct views that were in here. This is a logical model that we're looking at in this case. You can see here it has, I'm sorry, I'm going to go back, has a view from the taxpayer's perspective. So what do taxpayers see about it? Some of those are common. The clients looked at it from a different perspective. The governance view was considerably more complicated, as many things from a governance perspective are. From the program delivery view, again, another set of constructs there. And from the vendor view, it was that way. Only when we look at it all together did we come up with a total version of the model in order to do this. And this, of course, completely useless if we don't actually have a business glossary in here that defines the initial concepts for those models and engages the business communities in discussion about these particular definitions. And that another wonderful piece, I was at Microsoft in pre-acquisition. Nokia is a really fascinating company. Started out doing tires, rubbers, electronic commerce, mobile phones in order to do this. And what happened was the Nokia people decided to build a entity of, in this case, English terms. We also use it for terms that were really useful from the data perspective as well. And they built this out in a very, very inexpensive way using a single web page and a browser. And it worked extremely well in order to come up with this. Each of these terms then becomes important. When I got there, these were literally pictures from the very first day I was there. Everybody had one of these in their office. We said, what are these things? And they said, oh, that's our cruiser collector, and handed me a 50-page manual on how to use the Nokia cruiser collector, which was their way of recycling in those days. Once again, really, really interesting. Remember, our concept here in Conceptual is to look at these things from a re-engineering perspective. Let's dive a little bit further into logical. Again, this is our second set of washing machines, double-deckered and double all the way out on this. Again, the motivation here is to provide data specifications about size, shape, provenance, functions, uses downstream. It frees discussions from the technology considerations. The most difficult thing to do during any design or requirements exercise is not do the opposite of that. So in other words, if you're doing requirements, the hardest thing is not to do design. If you're in the process of designing a data model, the hardest thing to do is not think about how it's going to be implemented in Azure, Oracle, SAP, whatever the particular piece is. It's very important that you keep those things distinct in order to do this. Standard reporting does not provide standard definitions don't provide the conceptual context. For example, if I say bed, somebody who would sleep in is typically the definition that somebody would use in there. And yet, if I notice that in this instance, I was looking at a hospital bed, I had a purpose statement, said why the organization was doing this. And one of the things we found out was that a bed was associated with a room. And we said, oh, why is that the case? And they said, oh, well, we can use this capability. It was called before Wi-Fi tracking in this case, but it was a transponder type thing. So we said, well, what room is going to be the hallway? And instantly it just blew apart the entire process because, of course, a hallway can be anywhere. In fact, the main place that people get lost in a hospital is the elevator. What room is that? So once again, keep that in a draft form until it's actually validated. So you might ask the question, what's the relationship between bed and a room? Well, bed is related to a room. How are they related? Well, in this case, many room can relate to many beds. That's not terribly useful. So let's get a little bit more precise in this case. One room can contain many beds in this case. So that's our proper definition with us. Notice, by the way, read it in both directions. Many beds can be contained in each room, and each room can contain many beds. Until we refined that, it was really very difficult because we asked the question, what if beds can be moved? Now, there are different cardinalities that you can look at here. Again, exactly one to many, eventually 1, 0, one or more optional, and eventually one to many. All are possibilities, all have implications on the design in order to look at this. So a natural association between these entities, we're defining mandatory and optional. A bed is placed in one and only one room. A room contains 0 or 1 beds. In this case, that's the way it works. A bed is usually occupied by 0 or more patients, and a patient occupies 1 or more beds. All of these things at the conceptual level are important to understand because they will prevent you from having to go in and understand the specifics of how it's done in Oracle, but at the same time in business relationships so that the business people can talk to you about these. I've included lots of examples on all of these. This was a conceptual model that was used by an insurance company to help simply improve communication. They said these are the official definitions that we're going to use for these particular concepts. An analysis work product and became something that was placed around every associate's desk that dealt with this, and they were able to demonstrate measurable improvements in productivity as a result of coming around this. So again, that's sort of our logical piece. We get now to the final component of physical. Again, the right-hand side of our diagram on here. And again, this physical is as is and to be, as well as validated and unvalidated. This is the idea of production systems, looking at data flow diagrams, entity relationships, and the glossary in there. What would anybody handcraft DDL in today's environment? There's tools that do this stuff, including the AIs, which are much more capable of doing this than people. It's not to say that you should trust the AI fully, but it can do 80% of the work for you. That's great. By the way, if you don't look at AI output and try to break it, you will never do so. So reward people for trying to break the AI, but also reward them for using it as well. You must have this physical stuff in order to put things in production. These become the blueprints that are out there, and they help us with the future maintenance. So the physical data models exist and are foundational in terms of this. It's the description required to access the data in the system. If somebody wants to get data out of your system, they need a map in order to find it, and these are the maps. They can often be reverse engineered semi-automatically. Sometimes it'll come fully automated, but most of the time it's a semi-automatic process, which is still much more efficient than the old way that we used to do it in this.
Again, the physical models are a specification of the data that's accessed by the application, and they talk about the current and future data elements that are maintained in order to come up with this. Again, keep in mind the word draft. So how is data stored and represented? Well, it's a list of persons, places, or things that need to be created, read, updated, or deleted. Some people include archives, and these are the attributes that are important in order to have this, in order to come up with all of these various basic ideas. These are characteristics of things. Attribute of me, as you all know, is that I'm old enough to be able to consume adult beverages in the Commonwealth of Virginia. That would be a characteristic of that type of thing. So let's give an idea of what can be learned from this. Well, here's a little quick model of clubs and regions. So here's a data structure, a table in this case. It says region as club ID, and it's got some club reporting information here. Here's a relationship between the two. One region can have multiple clubs reporting to it, but each club must report up to one and only one region, no overlapping between them. We add in some other components, region name, region weather. Well, something about these clubs has to do with the weather. So the clubs can be identified individually and separately from another by marking it with a hashtag. That's just making sure that everybody understands that's the key. The club information is specifically maintained, and some organization exists above the club level, which again is that regional concept. In order to take a look at this, each club must be part of a region in order to understand this. All of these models can tell you things specifically about how they are put together. So an organization might describe the characteristics of parts of the thing, whatever it happens to be, and maybe give the reasons for it. Then the decision to manage each attribute has a direct consequence. If the above attributes are organized into a table, then there has to be a reason that the table is reserved. And all clubs have shared status. Reservations can be assigned with any sort of reason, as in free text. Somebody can write in anything they want to, which will probably require somebody to come along with AI and data mining at some point in the future, but that's okay. And the description is going to be unique for each particular club. Once again, got to have that mandatory component in order to pull it all together of the tag. So data modeling requires us to discover, analyze, and scope requirements. Understand what are the data things are, what do they do, and how do they interact. It's kind of like this is a metaphor that I got from my Finnish colleagues looking at a screen trying to figure out what's on the other side of it. It was snow in this case that they were looking at. And we're trying to reduce the snow and make it more clear because they map critical business assets. They compose and contain metadata that's essential to the data consumers, and they function as a street music language. So again, if you're with a group of musicians and they don't know the music, they all have to have the same, literally, piece of paper, same page in order to do this. And the process is iterative and may include multiple versions of conceptual, logical, and physical models. To show you how different each of them are, I'll give you an example in just a second. Again, each model is done for a specific goal. Now we have to have different basic database structures. There's a flat file, a index sequential file, a network file, a hierarchical database, a relational database, plus all of these other things that go into the middle here. Lots and lots of variations back and forth. Very few, if any, of these are taught in college and university. Most of the time they have to come to a DATAVERSITY webinar in order to get this kind of education. Let's take a look at one in particular. This was a wonderful piece for our student database master system that we had at one of the universities that I was working at. And it's very difficult to read, I know, but if you look in the upper left-hand corner where everything is connected, it's clear that the student database master connects to lots of these other pieces in order to do this as the parent. Here is the model they proposed, model they proposed to give us as a replacement to it. And hopefully you can see there's a big difference between the two models. Not at all a chance that this could work out as well. I've given you an example in here from an HR model. This is a conceptual model, a logical model, and a physical model that I'm just going to run through. Not that I'm going to give it to you in any sort of detail here, but you can use this to go back and map back and forth between each of these various bits and pieces here. So what we've looked at here is this overall set
of how to do modeling within this framework: conceptual, logical, and physical, as is and to be, and then validated or invalidated. There are correct ways to organize the data. Again, all modeling is done for flexibility, interactivity, retrievability, et cetera, and we're going to come up with these things. And if you don't, it will be very much problematic on us. Finally, don't tell them that you're modeling. Just write some stuff down, and then arrange it to make some appropriate connections between your objects. You'll be amazed at how many people will come back and forth to you and say, oh my goodness, I didn't realize you were data modeling. So the reason we're locked in this room is to understand the relationship between a soda and a customer. Okay, that's one way to take a look at it. We want to know what the deal of hospital beds is. And again, how does our perspective change when we understand we're going to use beds to track patients? If you've been to the hospital recently, no, they don't do that anymore. They put something on your wrist and figure out how that works out. And finally, could our systems handling the following business rule tomorrow? Is job sharing permitted? And once again, if we don't have that in place, there's absolutely nothing for you to take a look at on that. So just to finish up here, again, lots and lots of pieces. We'll go through this because we've already talked about it, but we do have to go through this iterative process, focusing on one particular step. And there is lots and lots and lots more to be learned from this. So take a look here. I've included some additional guidances or DIMBOK references, lots of work cited. My colleague David Hayes has a wonderful book out there. Bernard Talheim, who I understand Professor Talheim is retired, but his work is still out there. And I will actually be distributing a paper of his with the reference of this. And of course, Gordon Everest has done some fantastic work out there in order to do this if you want to learn more. And with that, we're at the top of the hour. Shannon, I think I ran 1 minute over today. Bad me.
Oh my gosh, it's market in history. The moment you went past the full hour at the top of the hour. I love it. No, Peter, this is so great. Thank you so much for another great presentation. Lots of questions coming in already. If you have questions for Peter, feel free to put them in the Q&A panel, and I will go through those today. So diving in here, Peter, is the demand for data talent lessened or impacted at all by the use of AI? A few years back, people were being told to learn to code. Not so much anymore with AI doing some amount of the software coding these days.
Very interesting question, very perceptive. Yes, you're exactly right on what you're describing. Computer science is now considered to be the most unmarketable degree out there, which is such a shame because, of course, it's not really the case. But as usual with our pendulums, they swing too far one way and swing too far the other way. It's always been a tough sell to sell the business value of this. And so hopefully I've given you some snippets in here in terms of how to sell yourselves, how to sell the concepts in here. Most people have said not just that AI is doing it, but in fact, the cloud is taking care of this. And the problem is it's a case of garbage in and garbage out. If you have a cloud input in there, and I will say this absolutely uncategorically, the biggest complaint on CEOs' desks these days is the size of their cloud bill. The problem is that shouldn't even be a CEO concern. It should be a CIO or a CTO or even a CDO concern. It's really, really horrible in terms of what they're doing. Looking at it, it just so unfortunate to do this. So back to your question, my sense is that most data scientists are given a little bit of data modeling. They're typically more given access to SQL and learning how to retrieve data, but they don't tend to know how to do data design. I'll give you an instance of how bad this is. And forgive the Shannon, at least you're living on a farm these days, so you'll appreciate it. I was involved with a worldwide study over 20 years worth of data collection that had fecal collections from more than 100,000 people spanning a 20-year span. And they did not have any sense that they needed to pay attention to how all that stuff was organized. And by golly, it hurt them in terms of their effectiveness. So I would say that the need for it is increasing because data is increasing, but it's also becoming increasingly important that you articulate that need yourself
to the people that you're trying to get the work from. And I know that sounds a little bit rough, but believe me, after the CEO has screamed and said, why is our cloud bill so bad? Or why is it we collected literally poop from hundreds of thousands of people around the world for 20 years and didn't have a plan to organize the data? That's a problem. We don't want that to happen to any of your organizations. Great question. Thank you.
Agreed. So, Peter, if organizations aren't modeling, what are they doing instead?
They're relying on what's being provided to them from the vendors. Once again, without mentioning any names, I was working at one organization that was having trouble. The proverbial CEO had already yelled at the rest of the people, why am I paying X number of millions of dollars per month for this cloud service, which you guys told me was going to be free in order to do this? And when we look at it, it's just the case that this organization was being charged 40% surcharge over top of their storage bills. In other words, if their cloud bill was $100, they were getting charged an extra $40 on that $100 because the vendor was saying, in addition to having your data in there, we are both managing and governing your data in the cloud. Well, I'm sorry, neither of those things were happening. And when we asked them to produce evidence that they were, it was absolutely crazy. So take a look at your governance efforts. And part of your governance efforts are that if they're planning to build something and they don't have at least a model of what they're going to build, and very little gets built in today's environment without the model, without data in there, they don't have a data model for it, then they are really committing malpractice at the corporate level in order to do it. There's no other way to describe it. If somebody said to you they were going to build your house, and how are you going to build it? Well, we're just going to make a picture of it. No, it doesn't work that way at all. You have to have a proper model in order to put up. In fact, here, Shannon, let me just pop one thing up. You'll get a kick out of this. Let's see, where is it? So here's a model that I put together for doing a home improvement. It was around here. Oh, for goodness sakes, why can't I find this stuff? Data organization, right, guys? There we go. There we go. So here is a model of a construction project that I was putting together for this particular piece. Something to keep me occupied in the wonderful hot days of the summer here. Anyway, yes, you absolutely will need to have that modeling. You absolutely will need to have people working towards that model, and it's a critical piece of things going forward.
Perfect. So, oh my gosh, so many great questions coming in. So, Peter, how to model data transformation? So, for example, ETL and ELT, are there any standard languages we can use?
Definitely let's not talk about languages per se. Let me jump to a slide here. There are about 5 or 6 different data modeling languages that people use, but virtually all the profession has agreed on something called information engineering notation. And that is what's being shown in this particular slide here with the crow's feet as opposed to the other types of things here. And the mention of ETL is a really important one. Even though your data may be moving through something, I know so many data engineers that have gotten really good at creating faster and more efficient ways of moving data around their organizations, but they don't have a clue as to what's happening inside of it. So using ETL as a source of metadata is a really phenomenal way, because if the ETL is in production, it means there have been at least 2 groups that have agreed on what the basics of that data being represented back and forth is. So even though your ETL groups may not realize they are a source of really good metadata and really good data modeling pieces, but you don't need a special language to do this. It's really a matter of following the steps that I described, creating some entities on a piece of paper, talking about the characteristics of how you would identify one instance of something versus another instance of something, and then connecting them together for the relationships between them. And in an ETL situation, you pretty much can stay with the physical as is and physical to be pieces. However, if you're going to make a large change, a redesign, because you realize you're supporting the wrong strategy, the strategy most things are built with is the fastest time to get something in production. Many people think of that as the minimum viable product. It's it's great, it works fine. We just happen to make, we run it fine with 1,000 transactions an hour, but when we scale to 1,000,000 transactions an hour, we realize we're going to have to pay a lot more to our vendors in order to support that. Again, really great question and really important there. I did not put that in the thing, but I've taken a note to incorporate it next year on the ETL component. It's a really good point.
Indeed. So, Peter, tell me, what happened to the business function models, or do we do data models in the blind way?
Again, great question. So a business function model is a different type of modeling. However, it can be integrated and is integratable with the data model. So let's take a very basic piece, which is a CRUD matrix. Many of you are familiar with CRUD matrix. It shows the interaction of data and processes. In fact, gosh, let me do, Shannon, I think we can find an example here real quick. It's terrible. I'm going to have to make sure I include these slides, but that's good. You guys are asking great questions. In order to come up with this, let's see, this was. I'll go with that. I'm showing you guys a very poor data access capabilities here, but let me find, bear with me for just a second here, because I guarantee you we will find a good piece out of this. Here we go. There we go. All right, now could I put my finger on it right away? Number 2. Okay, here now. Not part of the course, but it was a great question, so let's quickly run through it. CRUD model indicates the interaction between a process model, one other way of describing that is a business functions model, and the data. And what it's saying is that process A creates the data, and it creates data item 1. Process B reads data item 1, which means process B can't read data item 1 if it hasn't been created. So we now know there's a dependency between process A and process B. Process C updates the data, which could occur anytime after process A has created the data. Process D deletes the data, but probably can't delete it until after it's read it, just to make sure it's actually reading the right piece of it. But let's take a little bit further than all of this. We need to make sure we have a context model for all of these pieces. And the context model has in place a data architecture model or a business function model in order to do this, as well as a data model. In other words, you cannot do a CRUD matrix if you don't maintain a data architecture and a process architecture. And if you don't maintain these, you have no ability to actually understand the insight that's happening in here. Sometimes this knowledge exists in terms of some people's heads. Most of the time it doesn't in there. So again, great question on this. The whole point of a business function model and any model in general is to solve a business question. Why am I building this model? I'm just picking this one out of the thing here. Well, we needed to understand the difference between rooms and beds and patients. And if I formalize this particular piece of it, I now have a set of business rules, just as I did very back here at the start, of what's the difference between data, process, and information and all this. In your business side of things, you're asking a question of when or what or under what circumstances does this business process occur. So again, each model is done for the point of answering a specific question. And if you don't have the questions in the first place, you probably don't have a need for the models. But I guarantee you that very few models in today's environment do not involve business processes or data.
Thank you. So many great questions. And we have just about 15 minutes left. We've got time for several more. So continuing on here, Peter, how much data modernization can we expect in a typical system reengineering initiative? Platform modernization was important at my organization.
Really great question. Once again, I can't tell you the number of companies that have asked me to come in and, quote, help them get off the mainframe. And the real problem is not the mainframe. The real problem is they have bad data feeding the mainframe in there. So the question, I think, specifically is asking for, let me pull this up, trying to say, as you're going through this process of re-implementing your particular articulations around this, where on earth, to what degree is the data modernization component going to go into this? And I think the answer is unfortunately not enough. What tends to happen is people do that lift and shift thing that I was talking about earlier without any consideration to the fact that the data may or may not have been normalized to an optimal degree. And remember, you don't just normalize for the sake of normalization. You normalize to make sure that the data model supports the organizational strategy. So I think the answer, not enough, is the right answer, but I wish more organizations would do this. But here's a way to go back and make yourself really unpopular at the meetings that you have with the vendors and the teams that are implementing this. One of the things you could ask is, what do we have in here that is going in this process of moving the data from place A to place B that's going to guarantee that the data in place B is of at least the same quality as the data that's in place A? Even just moving that, just like I just did right there, usually ends up with the data in place B and 2B being of less quality than the data that it was in the source system. And if you don't have a place in the mechanism in place to measure the data as it starts out and to measure the data where it ends up on the destination, you have a likelihood of having something not be the desirable outcome. So I hope that makes sense when I say not enough. In most cases, the data model was simply put out there by a vendor, and the vendor is trying to solve everybody's problem. So you have a sort of lowest common denominator approach to making sure that the data supports the organizational strategy. And that what we need to look at from this point going forward is to make sure that the data being organized to support the organizational strategy. It may be simple, like, oh my gosh, I'm paying too much of my cloud bill and I'd like to have a lower cloud bill as a result from this. You can organize your data to do that, but any data organization is going to require some aspects of physical and conceptual, and logical modeling in order to come up with that. Once again, great question. I hope I answered it right.
I believe so, Peter. So at an enterprise level, when there's multiple databases, so relational, NoSQL, and many more, there's always some redundancy and logical model fails. Any best practices there?
Once again, the goal is not to have no redundancy in data models, but to understand what the redundancies are there for. And most importantly, not just you understand them, but document them so that when somebody comes to take a look at the design that you built 5 years after you're gone, don't get me wrong, some of you may like to be called on the phone 5 years after you're gone and say, hey, what were you doing there? In order to do that. We've had this happen many, many times. We had an Air Force base in Texas that we were working with and had to ask some questions like that. We literally had to call these guys who were in the VA hospital, and say, hey, we hate to bug you, but, we know you're going through challenges around your health. But can you go back to the data modeling stuff you guys were doing back in the day? In this case, we were lucky enough to be able to have commanded. You can always command a high consulting price coming in there as well. It's really key to document these assumptions. I'm making this assumption because we're optimizing it for speed. We're pretty sure that our volume per day is never going to exceed 10,000 per second, and therefore we'll be perfectly okay to put it in this way and to make these decisions because we're only going to be dealing with a certain amount. Once again, another very large bank organization that we helped rebuild their back office trading system a while back figured that they could handle up to 10,000 errors that occurred each day. And when they hit 10,001 errors, they literally would shut down their trading floor, which, as you might imagine, made the upper level management absolutely crazy bonkers. Why are we shutting down our trading floor? Well, we've made 10,000 errors and we can't afford to make any more because we won't be able to correct them within the time frame that existed at that point in time. Is a 3-day window that they were looking at. In order to do that. So just being able to say, yeah, we can make more than 10,000 errors in a day and it won't kill us as a bank was critically important. Again, great question. Absolutely great question.
Yes, indeed. So many great questions, as we keep saying. So what AI data modeling tool has someone used so far or recommended?
I have not seen any AI incorporated into any data modeling tools yet. That just maybe I haven't looked hard enough. But on the other hand, as I mentioned in there, AI does understand the concept of data modeling, data governance, other types of concepts very well. And so I don't want to say that you absolutely can rely on them, but if you're not using them, I consider yourself professionally being underutilized at this point. So a data model, the ChatGPT and Gemini and all the rest of them understand DLL as you bring it in. You can also read in data dictionary components in there in order to do this and have it do all kinds of things around optimization, modeling, just good old quality assurance, data quality checks. There are all sorts of things that you can have this do. You can take, and many of the things that we used to do in the data profiling world, if anybody remembers back to those days, where we used to have to go down and do statistical analysis of each row and column in the tables that were there. These systems are fully capable of helping out. Once again, helping out. It's not the idea that you want them to do the work and you simply put the question in and go with the result. But if you start to use them in a collaborative fashion, you will find that they can be of tremendous assistance in here. They understand tables, they understand rows and columns, they understand different types of database organizations beyond the ones that I mentioned in here. Again, you can go to columnar databases and then data lake houses, all sorts of things. Tremendously useful in order to do this. But it's going to be the idea that you, as a data modeling professional, are going to start asking questions and, if you will, getting a little bit like this is an intern or something that you want it to go off and do. It's a really good way to think about it.
Yeah, there was a comment added that another attendee has used AI to help understand how a data model can address specific business functions. So it's using AI to model.
I have asked AI to give me questions on specific companies. So if I'm working for company X, I've walked in front of management, asked ChatGPT, what are the data quality problems commonly associated with company X? Like, oh my God, you can't ask that question. That'd be releasing our information out to the public. It's like, no, this is what the public already knows about your organization. Remember, it's read everything it possibly can read about all of these people. Yes, tremendously useful. There needs to be, well, I happen to teach one, but in most organizations, most school programs, they need to teach a course on how to use this stuff much more effectively.
I love that. So, Peter, what do organizations use for transactional business operations if they don't use 3-tier data modeling architecture?
I want to say COTS, which is not really an answer. But in today's environment, you have a choice of, wow, we could build our own transaction-based system, or we could use SAPs. And again, not that SAPs is good or bad, but SAPs is optimized for SAP. And if you want to change the way SAP works in support of your organization, you'll have to do some customization work in order to do this. One of the main reasons that SAP projects are so expensive is because they don't use the right tools when they're doing this. Again, in the hundreds of SAP systems I've worked with over the years, I would estimate less than 10% of them incorporated data modeling as they were thinking about the process of changing the SAP system to better support the business, because of course they like to work on the process area, and that process area is much less well documented and does not give any insight into how the data would be processed. Again, just a very simple example there, but if I'm going to start aggregating information across different customers, because I've discovered that these two customers have complementary business practices. In order to do this, I have to access this table 10 times for every query, that if I had a different data structure, I could access it one time, which means that the overall value to the customer would be considerably strengthened in that area. And that's a little bit of a dense example. I apologize for that, but just relying on packaged software, you're going to get the lowest common denominator on there. And if they do try to change it, you need to make sure that changes are based on good modeling, not just data modeling, but process modeling and data modeling, in order to come up with the optimal result.
Thank you. And, we have about 5 minutes left, so I'm going to try and slip in at least one more question here. At enterprise level, with multiple relational database vendors, NoSQL, and many more document databases in place, logical models fail. Oh, so we already, sorry, I already asked that question. I'm just going to read it again. It's such a good question. So Peter, accept my apology for this all too common question. I know the recording will be made available. I'm just going to read some. Oh, wait, sorry, Peter. Can you recommend a good offline AI tool for more sensitive data modeling?
Oh, great question. Yes, short answer to that. Again, let me pop up the one that I use here, which is called Anything. That just, my company happens to be called Anything Awesome, so that's a different piece of this. But Anything is a really wonderful AI-based tool. Anything LLM, it's free to use, and you can run it 100% on your computer. So you do not need the microphone. Nope, don't even want to give it that on here. But again, some very, very nice pieces. Todd and I, my book writing partner, and I are using it right now to do some analysis of some conversations in here. It is a terrific, terrific little package. I'm sure there's others that are out there. I'm just, I let Todd look over the market, and he came back and settled on this one. So this is the one we're using. Anything LLM runs entirely on your machine, which means when you ask it a query, sometimes it's slower than it would be out there in terms of doing things, but it performs really, really well. So yeah, thanks for the question. Nice plug for Anything LLM. Oh, no fee either. It's free to download.
Where does it store its data?
Locally on your machine.
That's all nice. I love that. I love this question. So, Peter, when will you release the AI version of yourself to do our modeling for us? That's the best question.
I'm going to suggest that the AI is better than myself anyway, and that you should skip me and go directly to your favorite AI tool. They're all very good. I have not found major problems with it. What I found problems is the way people rely on them incorrectly. So again, start to play with this, start to use it, and you will find it's very easy to get up to speed. And if you have a question, guess what the best source of asking your question is? The AI itself. So really, really wonderful from that perspective. Thanks for the question there.
Great question. All right. Well, everybody, thank you so much for all of these great questions. It's been a lot of fun. Another great webinar, Peter. Thank you so much. As you can see there, we hope you can join us in August for 4 effective metadata strategies. I'm excited to hear what the fourth one is, Peter, because you evolved and added. And I hope you all have a great day. Thanks for all of your questions. To answer the most commonly asked question, just a reminder too, I will send a follow-up email by end of day Thursday for this webinar with links to the slides and links to the recording. Thanks, everybody. Hope you all have a great day.
Thanks, Shannon.